Alright, welcome back to this lesson. We're going to look at different types of, or different forms of a linear equation. In the previous lesson, we got what I call the definitional form, which is ax plus by equals c. I also will call it Bob for the back of the book form, because it's the cheapest to print. Now, let's just make up a problem and let's try to motivate a need for other ways to write this and how we can get there. Let's say that we have a line that passes through 1, 3 and 4, 5. Okay, well, we can sketch those points easily enough. 1, 3 and 4, 5. And we can connect the dots, and there's our graph. Previously we learned that we can calculate the slope. The difference in the y-coordinates, 5 minus 3, divided by the difference in the x-coordinates, 4 minus 1, which gives us 2/3. So we could plot nice points if we go over 2 and up, or go over 3 and up 2 every time. We could get to nice point, what I call nice points, ones that have nice integer addresses like 1, 3, and 4, 5. We go over 3 and up 2, we're going to get to 7, 7. Because we went over 3, 4 plus 3 is 7. We went up 2, 5 plus 2 is 7. Or we could go back 3 and down 3, and we would be at go back 3 and down 2, not drawn to, obviously I haven't drawn this picture well, because if we go back 3 and down 2, we're going to be at -2, 1, which isn't on that line. Okay, so let's just erase all that, because I didn't draw that line well, because I'm not drawing it to scale. Anyway, so we could find these nice integer points on the line. Well, what about if I want to know, like, the x and y intercept of this line? What if I want to know where it crosses the x-axis and where it crosses the y-axis? Or what if I want to plug in x equal 2, what's the corresponding output? Or when is the output equal to -5? What was the input that causes that? Okay, so we have a problem because I don't have an equation for this line. I have a picture for it. I only have 2 points that it passes through. But if we take our time and draw it somewhat to scale, 1, 3, 4, 5. We can staircase our way to points. We already went over our slope was positive 2/3. So we went over 3 and up 2, and we get 7, 7. If we go over 3 and up 2, we're going to get 10, 9. If we go back 3 and down 2, we're going to get to -2, 1. Back 3 and down 2, we're going to get to -5, -1. So I can get all these points on this line. And notice what happens. We had the original 2 points when we did the slope of 1, 3 and 4, 5. Well, what happens if you take other points on this line? Let's take 7, 7 and -5, -1 and calculate the slope. So you'll get -1 minus 7, the difference in the y-coordinates, divided by the difference in the x-coordinates, which is -5 minus 7. So you get negative 8 over negative 12, which is both divisible by negative 4, and you get 2/3, the same answer we got when we calculated with the original 2 points. The reason the slope doesn't care what 2 points you tell it. It's always going to give you the same number for a single line, because in the first calculation when we did 1, 3, and 4, 5, we calculated the slope there. We did the rise over the run. And then in the second one, I did 7, 7, and negative 5, 1, and got that rate of change for this rise over this run. Well, the red triangle and the blue triangle are similar triangles, and the relationship of similar triangles is that the ratio of their sides is always constant. So this vertical side divided by the horizontal side in the big triangle is equal to the vertical side divided by the horizontal side in the little red triangle. So it doesn't matter which 2 points you pick for your slope. The slope formula didn't specify which 2 points, x1, y1, and x2, y2, you had to pick. It just said any 2 points the line passes through. So if I take that and let's do the following little manipulation to it, or thinking about it. Let's let x1, y1 be a specified specified point on the line whose slope is m, and let just generic x comma y without any numbers be a generic point on the line. Then what has to happen, we specify this point x1, y1, and we have the slope, some value for the slope. Then we're going to let x comma y just be the general representatives of the point on the line. Oh, sorry, stretching. So what has to happen is that these 5 numbers, x1, y1, x and y, and slope, have all got to satisfy the slope relationship. The slope has got to equal the difference in the y coordinates divided by the difference in the x coordinates. So I have my players from the previous slide. Let me just copy them over here. I have my specified point, where it's going to be some set of numbers. I have my generic point, x comma y, and I have my slope. Well, if I plug them into my slope formula, I get this. If I rearrange this algebraically, multiply both sides by x minus x sub 1, I get y minus y1 equals the slope times x minus x1. This form, this is still a linear equation because my variables x and y are both just raised to the first power. So it's a linear equation. But instead of being in the definitional format, we call this the point slope format. It's in point slope form of the line. Because what you need to get to this form is you need a point, x1, y1, and you need the slope, m. Again, highly creative labeling from the mathematician. So in our example that we've done, we had 1, 3, and we had 4, 5, and we had the slope of 2/3. Pretty sure, I'm just going back and checking. Yes, 1, 3, 4, 5, and 2/3. Well, I can now get an equation because I can plug my players into my point slope form of the line and get an equation that then I could go answer all those motivating questions earlier, because I can use, all you need is 1 point. Here I have 2, so I have more information than I need. So pick your favorite point, either 1, 3, or 4, 5. Great, someone said 1, 3, thank you. So if we plug in y1 is going to be 3, x sub 1 is going to be 1, and our slope is 2/3. Then we get a perfectly acceptable equation for the line. We get a perfectly acceptable form of the equation of this line. I know, I hear you all out there going, but we didn't pick 1, 3, we picked 4, 5. Okay, for those people, quit your belly aching. I can get you happy, and I would use x1 equals 4 and y sub 1 equals 5, and I would get a perfectly acceptable form. Y minus 5 equals 2/3 times x minus 4. Both of these are, they represent the same equation. It's just a slightly different starting point than, because you're anchoring on this top one at 1, 3, and someone else is anchoring at 4, 5. Okay? It's just two different names for the same, two different labels for the same line. Like, I answer to Dr. Rogers, I answer to Mr. Rogers, I answer to Keith, I answer to Dad. All sorts of names for the same entity. Okay? But now, if we wanted to figure out, let's go get one of those motivating points. Like, what is, if x equals 2, then y equals what? Well, I could plug 2 in and get y minus 5 equals 2/3, 2 minus 1. So y minus 5 equals 2/3. So y is 5 and 2/3. So I could answer any of those questions now. I could plug in the y value and figure out the corresponding x value. I can also take this form, y minus 3 equals 2/3 x minus 1, and do some algebra cleanup without any specific x and y values. We'll distribute the 2/3, then we'll add 3, so we get y equals 2/3 x plus 3 is 9/3, so this is going to give us 7/3. So I get another form of the equation, y equals 2/3 x plus 7/3. If we do that same thing to the other half of the room's point slope form, y minus 5 equals 2/3 x minus 4. Notice what happens. We distribute the 2/3, so we get 2/3 x minus 8/3. Then we'll add 5 to both sides. Well, 5 is the same thing as 15/3. So we end up with y equals 2/3 x. Negative 8/3 plus 15/3 is positive 7/3. The exact same form that we got. It's just a little more compact. You just have y equals. This generically is written as y equals mx plus b. Notice that this number in front of x was our slope. So in this form, y equals mx plus b, m is still the slope, and b is the y-intercept. This form is called the slope-intercept form. Slope-intercept form. Because because that's what you need to build it. You need the slope and the y-intercept. Or that's what the values are that you get for slope-intercept. Okay, so we have three forms. Ax plus by equals c. Y minus y1 equals m times x minus x1. And y equals mx plus b. Three different ways to say the exact same information to get an equation of any line. I personally don't care which form you use. The back of the book would, let me check this current book, but no, he's doing some point slope form a lot of the time. Hold on. So you can use any one of the three forms if I ask you to find an equation of a line. Find an equation of the line passing through let's say it's passing through, I'm looking. Oh, let's just make one up key. 2, -5, and 4, 3. Okay, well, in both the point slope form, point slope, and slope intercept form, you need the slope. So if I'm asked to find the equation of a line, the first thing I'm going to do is go calculate the slope. So the slope of this line is going to be the difference in the y-coordinates, so 3 minus -5, divided by the difference in the x-coordinates, 4 minus 2. So 3 minus -5 is 8, 4 minus 2 is 2, 8 divided by 2 gives me a slope of 4. Okay, so now I have lots of information. I can write the answer in lots of different ways. I could write it as y minus -5 equals 4 times x minus 2. Typical book, they're going to make that negative minus and -5, rewrite it as +5. So if you see it written like this, it's still in slope-intercept form. It's just we don't like the negative because it can be written as a positive. So that'd be a great answer. Or if you prefer the 0.43, your great answer would look like y minus 3 equals 4 times x minus 4. A perfectly acceptable answer. If you want to write it in mx plus b format, we have the slope is 4, but we don't have, I've already forgotten my points for this problem. Sorry. Make you seasick. 2, -5, and 4, 3. Right? Correct. If I want to write it in mx plus b, which is the more compact form, it doesn't matter. Let me get that point across. I personally, Keith Rogers, don't care what format you tell me your answer. If you can get to a successful answer, I am fabulous. So if you want it in this format, my brain just went blank, sorry, then you can do one of two things. You can either go get one of these two formats and algebraically rewrite it. Okay, well, that seems like an awful waste. If you're going to pass through an acceptable answer, why would you spend the algebra time to rewrite that acceptable answer just in a different format? Okay, what I would do is, you know your slope, so plug that in. Y equals 4x plus b. What I don't know is the y-intercept. I wasn't fortunate enough to have the y-intercept handed to me. Okay, not a problem. I have 2 points. I have an x value and a y value. I have another x value and a y value. Plug one of these 2 points in for x and y. It doesn't matter which point you use. So like if I plug in y equal -5 and x equal 2, using this point 2, -5, well then, when I plug those in, I know everything except b. I now have one equation with one variable. Let's go solve for b. And we get b is -13. So the slope-intercept form of that line would be y equals 4x minus 13. A third acceptable answer. And if you want to write it in the formal back of the book definition, you just subtract the 4x from both sides, and you get -4x plus y equals -13, so that it looks like ax plus by equals c. My personal preference, if I'm going to be honest, I prefer mx plus b followed by slope-intercept form, followed very distantly by the definition form. And the reason I don't care for that, I mean, I deal with them all. Doesn't matter. To me, it's a format change. Someone wants to give me $20, I'll take a $20 bill, I'll take 2 10s, I'll take 2 rolls of quarters. I don't care. One of them, they're all useful in different situations. But both of these formats, when I see something written in this format, information jumps out at me. Like if I had -3/4 x plus 5, then I have useful information jumping out at me. I know the slope of this line is 3/4. I know that it crosses the y-intercept at 0,5. So I could graph that up here at 0,5. It's got slope of -3/4, so we go over 4 and down 3. That gives me the point 4, 2. I can connect the dots. There's my line. If someone hands me an equation in the form 3x plus 4y equals 12, one that we saw in a previous lesson, what's the slope? What's a point that the line passes through? You have no clue because it's written in this form. Now, if I wanted to get it into a useful form, like one of these up here, I would just solve for y and get 4y minus 3x plus 12, and then divide both sides by 4, and I get y equals -3/4 x plus 3. And now I've taken this and converted it into a useful form. I wanted to go, not carry around 80 quarters, 2 rolls of quarters for $20, so I took it to the bank and got a more useful format of a $20 bill, so I can just carry it in my wallet much easier. Okay, so the point of this lesson was to get introduced to these 2 forms of a line, the slope-intercept form and the point-slope form, basically, so that we can, given 2 pieces of information, we can go build an equation of that line. All right, I will see you next time. Bye.